Tim Gatotis suffered a spinal cord injury in a swimming accident nearly a decade ago. He's been in the chair ever since. He'd like to be able to do more for himself. That's what brings him here to Harvard University, where he helps test new wearable robotic devices designed for hand and arm rehabilitation.
I've been telling people about it because it's pretty exciting. It has given me hope. It seems like it's inspired me to get out and try to do things that I didn't think I could do before.
So basically every week or so, we're testing a new type of glove, a new type of sensor, a new type of control scheme, and using this feedback from our participants in our study to understand if we're moving in the right direction or not.
With support from the National Science Foundation, designer roboticist Connor Walsh and a team are developing inflatable, soft robots to help people like Tim regain use of their upper extremities.
When someone suffers an injury such as a stroke or spinal cord injury, they lose function. So one of the things that we're thinking about doing is how do we help restore their function so that we can enable these people to be able to be more independent. Our approach to doing that is creating very lightweight and soft wearable robots that people could potentially wear all day, every day.
Walsh says some patients could use these wearable robots short-term to rehab an injury. Others with more serious conditions might use them as assistive devices on a long-term basis.
Yeah, so I think the field definitely recognizes that some devices are maybe better for assistance and some are better for rehabilitation, but there's definitely a gray area between those two, and where if you're wearing a device that's an assistive device all day, every day, maybe that's actually helping you get better.
The challenge is making the robots comfortable to wear and intuitive to use. Sensors control the movement.
If we tap on the palm sensor, this is the mode where we help our wearers open up their hand first, and then if you maintain the contact or tap again, that will help you grip. During our design, we also put a soft release. The idea was that some of our participants could reach across and hit the sensor to release, but we also incorporated another external button.
They are made of layered textile materials with balloon-like bladders stitched inside.
On the top part of the glove, we might have textiles that can stretch a little bit more. On the inside part, maybe textiles that can stretch less. And it's that difference in the mechanical properties of those textiles that when it gets inflated, that causes it to have the motion that it has.
Team member and physician Sabrina Paganoni is testing new treatments for people with the degenerative muscle disease ALS.
Could you see this becoming part of clothing that you might want to wear?
She sees a growing need for these robots.
The need for assistive devices is going to continue to increase because people will live longer, which is great, as we develop new treatments. But at the same time, we need to be able to give them not just longer lives, but more fulfilling, more productive lives.
Tim has been working with the robots for just a couple of months, but he's excited for the future.
It's easy to get discouraged and think that you can't do things, and now that, like I said, with this glove and the shoulder harness, I just see different possibilities that just seemed like way out of the ballpark. And now it seems like I literally have things in my reach.
Designing wearable, soft robots to help people with disabilities help themselves. For Science Nation, I'm Miles O'Brien.